Hi, this is Saka, and I'm here to help you with your homework tonight on section 10.3. So let me get out my little scribble thingy so I can write. All right, so we're looking at number one. It asks about Kelvin temperatures using for which of the following gas laws. Basically, remember we always need to be in kelvins. Okay, has to, must. Okay, and the reason why that is because we can't be dividing by 0 degrees Celsius or negative values. Otherwise, we end up with numbers that don't make sense. So keep that in mind. So let me erase that, and then I will scroll up. Okay, so question two now. With question two, what we're doing here is we're talking about the ideal gas law. So remember, ideal gas law, we can express it in a couple ways. We could say P1 V1 over N1 T1 equals P2 V2 over N2 T2, or we could just say PV equals nRT. So let's go ahead and look at this question. If the ideal gas law, what is true? Does the pressure need to be measured in torr? No, not necessarily. We have other units of pressure that we could use. The volume can be measured in any unit. Or remember, R is always in liters, so I don't think that would be true either. The temperature must be measured in K. Well, you can look at the last question we just talked about. R must always be used. That's one we talked about today in class, and hopefully that makes sense. And the pressure must be used and it can be measured in any unit. That's technically true, but not actually. Okay, and the reason why is because the pressure units must match the units in R. So today we use 0.0821 as R. Now remember, this is R when the pressure is in atmospheres. So you just can't throw in any pressure you'd like. You have to use the units of pressure that correspond to the R. So we did those conversions today. So question three, what is true about R? R is always used in the ideal gas law. This is true. The numerical value of R is 8.21. That one, it depends. No, not really. R is called the gas constant. That's true. And then R can be units of liters times ATM times over moles times K. So this one is definitely true. Yes. Yes. This one, not really. And then this one is yeah. Okay. Moving right along. Let me erase and scroll down. Oops. Let me convert here. There we go. All right, so hopefully after today's practice, this stuff will be a little bit easier. So here we're looking for volume, so PV equals nRT. So we're solving for volume, so V equals nRT over V. And so we can plug in some numbers here. So we know that, oops, not P, it should be P on the bottom. So this is, let's see, you can plug in your numbers here. Remember, R is going to be 0.0821, and you have your other values, right? And remember, with this temperature, you have to convert it to Kelvin, and I think the rest we're good to go. Now, question five. Suppose two gases with unequal molar masses are injected to opposite ends of a long tube and are allowed to diffuse towards the center. So here we have our tube. And so let's say we have the heavy gas here and the light gas over here. Okay. Now, we said yesterday that the lighter gas diffuses faster. And remember, that was because the kinetic energy is constant for both gases, and that's equal to 1/2 mv squared. So remember, the lighter gas makes up, they have the same kinetic energy, so the lighter gas has to move faster. And so what ends up happening is if we let these things diffuse, the lighter gas should diffuse faster than the heavier gas. The heavier gas would move slower. Okay. All right, moving right along here. Scroll down to question 6. As a hiker climbs a tall mountain, he finds it harder to breathe. And why does this happen? Remember, as we go up in the atmosphere, the pressure of the atmosphere at atmosphere, M-O-S, I can't spell, atmosphere decreases. Okay, so as he goes up, there's less air, so it's harder to breathe. That's why you hear about, like, if you watch football or basketball, like when teams go to Denver where the elevation's higher, teams struggle sometimes with their fitness because they're not used to competing at a higher elevation where there's less oxygen to breathe. Okay, STP, remember, is short for standard temperature and pressure. Remember, we talked about standard conditions. Remember, the N equals 1 mole. The pressure is 1 atmosphere. The temperature is equal to 0 degrees Celsius or 273 K. And then the volume of any gas under these conditions will be 22.4, regardless of what kind of gas it is. There you go. Moving on. Okay, get my arrow. Here we go. Question 8. Okay, sample of oxygen is at 1.25 atmospheres and 24 degrees Celsius. What's its mass? So what we're doing here is we're using ideal gas law. And so the reason why I know this is because it's asking for mass. And so mass we can get indirectly by doing a mole conversion. Because we have the formula of oxygen. Remember, oxygen is O2 because it's diatomic. So what we would do here is we would solve for N. So N equals PV over RT, and then we would do the mole conversion second. So this would be number 1, and then second we would do the mole conversion. Okay. Moving down to number 9. So we have nitrogen with a pressure and volume at 50 degrees. And so here we have 2 sets of conditions. So we have P1 equals 1200 torr, and we have a V1 of 3.8 liters, and a temperature T1 of 15 degrees Celsius, which we know we have to convert to Kelvin, right? And then in the second condition, we have a second pressure where the pressure is 450 torr, and we have a temperature of negative 45 degrees Celsius, which we know we need to convert, right? Because we can't have negative numbers. And clearly here we're solving for V2. So this is an example of the combined gas law. So remember, the combined gas law is P1 V1 T1 equaling P2 V2 over T2. And then we can just solve for V2. All right. Swiping and moving on here. So for 10, we talked about directly and inversely proportional relationships. And remember, if you're not sure, you can always just use the ideal gas law. So P1V1 N1 T1 equals P2 V2 N2 T2. And remember, if they're above and below, like in numerator and denominator, that means that they're direct. But if they're next to each other like this, either in the numerator or denominator, it means they're indirect. So we can see that pressures is directly proportional to moles and to temperature, and volume is directly proportional to moles and to temperature. But if we compare P to V or N to T, they're indirectly proportional. Okay? And remember, when I say direct, so if I say direct, if one thing goes up, if A goes up, then B also goes up. So B and A are just basically just measurements. And indirect or inverse is probably better. Don't worry about indirect. It's the opposite, where one goes up and the other one goes down. So let's say A goes up and B goes down. Okay? All right. Moving right along here. Moving to 12. All right, so here we're going to use the ideal gas law again. They give you n's. It pretty much tells you what you need to do. So PV equals nRT. In this case, we're solving for temperature, and so we're just manipulating it, right? So T equals PV over R times N, and we just plug in our numbers. Remember, R is a constant. And remember, if you're going to use 0.0821, you have to convert that pressure. And because all these answers are in Kelvin, you don't have to worry about converting. Okay, 13. So remember inverse relationship we just talked about, if one goes up, the other one goes down. And so I'll let you figure that one out. Okay, last question I believe. So let's do 14. So we have a molecular theory that describes the microscopic behavior of a gas. One main point in the theory is that within a sample gas, the frequency of the collisions between individual gas particles and the particles of the wall container increase if the sample is compressed. So what we're saying here is the pressure increases. And so let's say we had our syringe here. And if we're compressing, I know it's a bad, if we're compressing the syringe, that means we're pushing down. And if we're pushing down, that means the volume is decreasing if we're pushing down. So hopefully you can identify which law, and this is an inverse relationship if you didn't know. And that is that, guys. Hopefully this will help you with your homework, and I'll probably try and shoot a couple more videos going over some theory stuff later on. So see ya.